Okay, so in this lesson, we're going to be looking at histograms, but we're going to use a log scale. So our log scales, alright, so yeah, we're going to be using a log scale. So it's always log 10. So on your calculators, you'll get log and then they'll have a thing there, and we're going to always have log 10. So why we do it is it's so that the scale, because we've got such a massive range with our data, that if we create a log scale, it brings the data back in and you can describe it better. So the best way to talk about it is like with this first histogram. Now this is the same data, and it's the weights of animals, let's say in a zoo or whatever, that they collected. So you can see this is their body weight. So we've got some massive, huge, it was probably not a zoo, it was just overall. So we've got this huge value of animal up there, and there's going to be probably, I don't know, what's the biggest animal in the world? A whale, a big whale. And then otherwise, and then if you go 0 to 5,000, that's where all the rest kilos, that's where all the rest of the animals are falling in. So it's not really showing us the distribution. So what we do is we change it to a log scale. And down here, this is a log scale. Now, all you have to do with a log scale, don't overcomplicate it for yourself. Just when you see the log scale in further, general maths, all you have to do is see that number there. What the actual number is 10 to the power of whatever's there. So that's 10 to the power of -2. If you do 10 to the power of -2 on your calculator, you get 0.01. Okay? So then if you see, I'm going to do this one as well. So if you've got a 0, that's actually 10 to the power of 0. Does anyone know what 10 to the power of 0 is? It's 1. So there's that. And then up here, let's do the 5. It would be 10 to the power of 5, which is 100,000. Yeah? To help you out, the number there on the log scale is how many zeros are after the 1, okay? So there you go. So that's pretty much all you have to do. Now, if you're given, we can follow this chart here. If you're given a number and you have to make it a log, you just go log 10, so we'll get that on our calculator, and you put the number in there. We'll have a look in a minute. If you want to go back, so if you were given a log number, so say, for example, we were given, and that's what up there, when you have a log scale, you're given the logs number. So if we have a 2 and we want to go back to the real number, we know a 2 means 10 to the power of 2, which is 100, which is what I explained. All right, so that's what we have to do. You don't really ever have to, you've got your calculators, and you're most likely just reading a scale on a histogram like that, okay? And it will condense the data. So let's have a look at the next page. All right, so just to help you with your calculator, I'll show you how to do this. So I'm going to pause it and we're going to look at the calculator. Okay, so up here I've put the original histogram of this data, just so you could see. It was like the animals, where it was very spread. All the data was in one column. It wasn't showing me anything. So they've now converted it here to a log scale histogram, okay? And then we're going to go through the few of the questions. So it says, what body weight in kilograms is represented by a number 4 on a log scale? So when you see a 4 on a log scale, it means 10 to the power of 4, which means 10,000, yeah? You can pop it in your calculator, and I'm showing you down here how you can just do it on the calculator if you like. Then it says, how many animals have a body weight of 10,000 kilograms? Of more than 10,000. So you need to convert 10,000 to a log scale, which was, if we already know it's 10 to the power of 4, but if you didn't know, you could do you can do log 10 to the 10,000 and you'll see it's a 4. So you want to know how many more than 4. So you could look off here and it says how many. Now it said there was 27 animal species. So we knew that was N. And because we can see more than 4, this is actually a percentage histogram. So more than 4 was 8%. So when you're looking at B, you need to find 8% of 27. When you do 8, you've got to change it to a decimal. So it'd be 0.08 times 27. And that's how we get, when it says, what did it say? How many animals? We say 2.1, so we probably say 2, therefore approximately 2 animals, yeah? Okay, and then C, the cat has a weight of 3.3. Use your calculator to convert it to a log scale. So we just do log 10, 3.3. It's here, how you do it. So it gets a log scale of 0.5. Now that makes sense because 10 to the power of 0 would be 1 and 10 to the power of 1 is 10. So the cat's somewhere in between a 0 and a 1, okay? And then the log, what it says, to determine in weight, so an animal that has a log weight of 3.4. So you just go 10 to the power of 3.4, and that animal is 2,500 whatever kilos, okay? So the histogram 2 below shows the weight distribution of 143 birds. So remember, we should just always take note, they're giving me the total. And then also take note what type of histogram it is. It's just a normal number frequency, a count frequency, not a percentage. So when they say how many birds weigh between, now they want 10 and 100. They're talking, this is real weight, not a log scale weight, yeah? So what is, we've got to convert 10 to a log scale. So if you do a log scale, 10 will be what? What to the power of what? 10 to the power of what gives 10?
1.
Yeah, so this one has a log scale of 1 because we know that this would be 10 to the power of 1, which equals 10. And 100 has a log scale of 2 because we know 10 to the power of 2 equals 100. So they just want to know how many are in between log of 1 and log of 2. So how many? You can read it off. I think it's 37, yeah? So we're going to say how many? We'll say 37. Sorry, and put the answer. Okay, here, question 3. The histogram below shows the population size for 48 countries. So N equals 48. Then I'm just circling this as a count frequency. And it says, based on the histogram, the number of countries with a population that is less than 100,000. So we need to change this to a log number. Okay, so you can, cheats way, you can just count the zeros. It would be 10 to the power of 5. If you wanted to check on your calculator, we just go log 10, 100,000, and you'd find that that equals 10 to the power of, that would equal 5, yeah? So you know that here, 100,000 is represented as a 5 on the thing. So it said it wanted to know how many are less than that. So I want this one and this one. So we've got, I think we read off that's a 7 and that's a 1. So you add them together, and how many are less than 100,000? 8, D, 8. Alright, so what we're going to do is we're going to create a histogram, and this is good practice so I can walk around and check people can do them. But we're going to do a histogram with a log scale. So the instructions are here, but I'm going to go through it with you in class.